A critical value is a z-score in the borderline separating the z-scores that are likely to occur from those that are unlikely to occur. The critical value notation is given as z sub alpha. This just means a z-score with an area of alpha to its right. So when you have z sub alpha, the alpha number is just the area to its right. You can use a table or a calculator to find the critical value, but both ways require you to do the exact same thing at the start. And that thing is you have to do 1 minus alpha to get the area on the left. Whether it's a table or a calculator, you need the area on the left. Once you have that area on the left, you can use either the table or the TI-83 or 84 to get the critical value. So let's look at a couple of examples. We're going to find the following critical values. The first one is z sub 0.05. Well, here we have our alpha value, which is 0.05. Now we have to do 1 minus to get the area on the left, since this is the area on the right. So we're going to do 1 minus 0.05, and we will get 0.95. Now that we have the area on the left, we are going to take our 0.95 into our z-score table and see what z-score is closest to that. So positive z-score table, and we're looking for the closest to 0.95, which is going to be right here. Now I've circled 2 because both of these values, 0.9495 and 0.9505, are the exact same distance from 0.95, which is right here in the middle. So what we're going to do is we're going to have a z-score of 1.6, and then in the middle between 0.04 and 0.05. So this is going to be 0.045. So our z-score is going to be 1.645. So critical value, 1.645. That's our critical value. But that's how we use a table. What about a calculator? Very simple. We've done it before. What we do is in our calculator, we're going to go to second and vars, and we're going to go to inverse norm number 3 and type in our area, in which case our area is 0.95, the area to the left, and then hit enter. And there we get 1.6448, 1.645, just like we got in the table. Exact same way, whether it's table or calculator, you will get the exact same answer. But let's do a couple more examples just to feel a little bit better about it. So let's find the critical value for z sub 0.10. Again, alpha is 0.10. That's the area to the right, but we need the area to the left, so 1 minus 0.10 to get 0.90. We're going to go into our table and find the closest to 0.90. So we're back here, just get rid of what we've done before. And we're looking the closest to 0.90, which is going to be right here, 0.8997. So the z-score that corresponds to it is 1.28. So 1.28 is the z-score that is closest to 0.90. So 1.28. And again, that is the table. Let's use our calculator again to just prove that it's the exact same answer. So second vars, number 3, and we're going to put in 0.90, and we get 1.28, the exact same answer. So calculator table, no difference, it's all good. Let's do one more just to make sure we are confident in our abilities. So let's find the critical value of 0.01. So again, alpha is 0.01. We're going to do 1 minus 0.01 to get 0.99. So let's look into our z-score table for the closest to 0.99. And 0.99 is closest to right here, 0.9901. So 2.33. So 2.33 is the closest to 0.99. So critical value is 2.33. And that is again with the table. No difference with the calculator, but let's just do it again to make sure. We're going to go to second and vars, inverse norm number 3, and our area is 0.99. There we go, 2.326, so it's 2.33 just like we got before on the table. So regardless of whether you use a table or a calculator, you have to do 1 minus your alpha value to get the area on the left, and then you look into the body of the table to get the closest z-score to it, or you can use inverse norm in your calculator to get the z-score as well, or for the critical value.